a group of islands with bridges connecting them. As anyone in the Vice City knows, the biggest fear of the Vice Cityers is that some days the islands will submerge. The big problem with this is that once the islands submerge, some of the other islands could get disconnected. You have been hired by the mayor of the Vice City to tell him how many islands, when submerged, will disconnect as part of the Vice City. You should know initially. Initially everything is connected. All the islands of the city are connected. Now I need to find all those islands how many islands when submerged will disconnect part of the city. Is it articulation point? I need to count the number of articulation points in this graph. Is it? Yeah. Because then only if that articulation point submerges, that will get disconnected. The graph will get disconnected. And initially everything is connected. So I just need to run one DFS and calculate all the articulation points from that. What is the input? NM islands and M the bridges. The M lines contains the interior U to V. There is an edge. There is a bridge connecting U and V. The input ends in case n equal to M and M equal to 0. Okay, I think we can write this. So while 1 and NM, let's read this. NM, if n is equal to 0 and M equal to 0, that means we need to break. Otherwise we have n nodes and m edges. Let's create the graph. Equal to 0 I less than equal to m I plus plus. So we have the graph. It cannot be global graph because consistency of. Let's handle the parallel edges also, which is Spoj is very weird. So adjacency of n plus 1, we have m edges and y adjacency of x dot insert the y and adjacency of y dot insert the x. Now we have the graph created. Let's run a DFS from 1 by passing the adjacency, who is the parent, and I think this should work. After this we will have all the articulation points defined. Let's have this also. Vector of the articulation point of. So is this an articulation point? It's a bool. Because once we have everything, it is an articulation point, we can go to all the nodes. So if the articulation point of I is true, that means we can do answer plus plus. The answer, and yeah, we can keep on printing the answer. I think it should be fine. NM and equal to 0, M equal to 0. Create the set. Is this node an articulation point? Create the boolean vector and have this adjacency x dot insert y insert x. Create a DFS from 1 1 adjacency. Answer is equal to 0 from I equal to 1 to n. If the articulation point if this is an articulation point, the node I, then answer plus plus. Okay, that's what we need to print. Now DFS should need also this articulation vector, adjacency vector, articulation vector. Let's write the DFS. What is the node? What is the parent? and vector of integer, or it is a set, adjacency, and set of vector of boolean. Is it an articulation or not? Is it right or? Yeah, let's see. Okay, this should be I think it should work. Okay, let's see. It is the how to find the articulation point. We need the low vector, high vector. We need to find the low linking. Then only. Yep. So you can say the pre-order number. The pre-order number of node U is nothing but count, and let's say count pre-order, and what is the low value of U is nothing but pre-order of U. Okay, now go to all the adjacency of U. Now I need to go to V. So pre-order of U is count, and let's say it is 1. It is count plus plus. So everything or should we pass it directly? Let's pass it. Who cares? So 1 1 and what is the count? I guess we need to pass the pre-order number also. The pre-order number of U is this value 1, and low of U is pre-order number. Let's have that also. Articulation point, pre-order number, and low value also. Pre and low. We can pass the pre and low. Pre-order number of everything is 1 minus 1, and low of everything is, let's say, 0. Doesn't matter what I put. So pre-order number of every node is minus 1. That means it is not visited, and the low value is 0. Okay. We pass the pre-low, adjacency articulation, pre and low, and U parent count. U parent and count. What is the count value? And then I think, yeah, let's write the DFS. So from U to V, so I can go to a back edge or forward edge. So if it is forward edge, then only. Okay, so if it is forward edge, then DFS on V with parent as U, count as same, and adjacency, pass the adjacency, pass the articulation vector, pass the pre vector, pass the low vector. Okay, so if it is less than 0, it means it was a forward edge. Yeah, but if it was a backward edge, it should be, so pre of U is not equal to -1. That means I'm visiting this node again. From parent I'm coming to U again, and it is a forward edge. and it is a backward edge because from parent I come to you, come to a node which already has the pre-order number. That means we just need to return the pre-order number. That means it will be positive number, yeah, but where we can update the low value of parent is nothing but minimum of itself, low value of parent, or where do I go, pre-order of u. Yeah, I think this is fine. Low value of parent will be updated with the pre-value of u and return the pre-value of u. Is pre-value of u count plus low value of u, pre of u. Go to adjacency of u. If it is less than 0, this is a forward edge. After this we know the value, low value of u, low value of v, because we have already, so we can update our low value of u will be minimum of low value itself. And what is the low value of this child? Now let's see if u is a bridge or not bridge, the articulation point or not. How to find this? Let's see. So if I'm at u, this v1, v2, v3, u. So if u is parent only from where I have started my DFS, then for u to be a bridge, for u to be an articulation point, the parent should have at least 2 nodes, right? Otherwise all the childs, if u is an, otherwise can I delete this edge? If I can delete this edge if and only if this parent's low value, means low value of this child is remaining inside, is remaining below this value, right? Then only if I delete this node, all these nodes will become disconnected. Yeah, that means this should be greater than equal to pre-value of the u, then u is a articulation point. Yeah, so but we need to handle that parent case also. So if u is not equal to parent, then only so u not equal to parent. If u not equal to parent, then this value, that the low value of v should be greater than equal to pre-value of u. If it is u at least 2 child, we need, if u is parent, then at least 2 child. How to find 2 child? Let's say boolean has 2 child is equal to false, then we can make it true after, then hash 2 true, hash 2 child, right? After this you can say, if this is the case, if u is not parent, then we check the lowest it can, the low value of v is greater than equal to pre-value of u. That means after deleting u, after submerging u, all the subtree who has root as v will be disconnected. Yeah, but if I'm doing it second time, then if I'm doing it first time, yeah, hatch child will become true. That means at least it is the second child. Yeah, it is the parent. Yep, that means articulation point of u can be marked as true. After this I think it should work. Yeah, let's see. DFS on vu, count, adjacency, articulation, pre, low. Something wrong with my Sublime yaar. Pre is an int and low is also an int. Great, it worked. My Sublime is working. Great. So 0 1 is the answer. Oh, yeah. So we submit it or just check once. NM 0. Remove the parallel edges. Articulation pre-order low value and go to create the adjacency adjacency graph, then DFS on 1 since everything is connected in the beginning, so we will need only one DFS 1 and the parent is 1. Yeah, this will handle this case. If u is equal to parent and it should have at least 2 child, has 2 child. Yeah, at least 2 child it should be. Yeah, then answer is 0. Go to every node. If it is an articulation point, answer plus plus. See out the answer. Fine. Is it an article? So how to find the articulation point? If I am going to a back edge, then we update the parent's low, which should be, that means parent can reach up till this point, up till pre of u count. So we can take the minimum of these two and return the positive number, so that it will return, otherwise return negative number to say that it is a forward edge. So forward edge only from u to v is a forward edge. I think v will be calculated by this, the dp of v calculated. So dp of u can be written as dp minimum of dp of u and the dp of v, right? Because v if goes to somewhere here, yeah, then it will be minimum. It's fine. Otherwise this case, if u is not equal to parent, then low of v greater than equal to pre of u. Yeah, if it is not the parent one, then the low of v means v should not come out of the subtree of u, then only there shouldn't be any edge in the child v, in the subtree of child v, which comes out of this parent node. That is what it represents. Yeah, then only we can delete u. Articulation point of u becomes true and hatch child is marked as true. I think it will work. Yeah, let's see. If it doesn't work, I'll stop here. This pause is very accepted. Great. I think it is easy to remove the parallel edges. We can use it, or we can assign the IDs and then do that logic in our DFS here. Okay, otherwise we check the, yeah, we are just calculating the low linking of every node, and from that only we calculate the whether it is an articulation point or not. So about bridges is fine. We can have this here, that the low value of v should be greater than equal to pre value of v only, then the u to v edge will be a bridge, and this is not required in that case. Yeah, that can be handled in other if case. I think, yeah, in only one DFS we can find articulation point, bridge, both. Okay.